Good morning, dear students. In the last class, I have taught you about natural language communication. So, I taught you how the machine can communicate with other machines. Okay? And I have also taught you about machine translation, how speech recognition can be done. So, all these things I have taught you in the last class. In today's class, I am going to teach you the last topic of our 5th unit, that is robotic. So, from the first unit, we have learned about artificial intelligence, various applications of artificial intelligence, various search strategies related to artificial intelligence. In the last unit, I am teaching you about the robotics. So, that is the final application, that is the final role of artificial intelligence. Finally, we are mixing all that planning, searching strategies, everything together, and we are going to create a robot. So, the last unit is about robot application, and the last topic is about robotics. So, if you see this anything in the world that can be manipulated, that is the object that can be moved from one place to the other place by a machine, you call it as robotic. Okay, you got it? So, any object in the real world that is moved from one position to the another position, or you call it as manipulation by a machine, then you call it as a robotic. Okay. So, what is a robo? Robo is nothing but moving a machine that moves an object from one position to the other position, or manipulates the object from one position to the another, you call it as robot. So, if you see this robot, mostly it is equipped with two things. One you call it as effectors, and another one you call it as activators or sensors. So, what is effectors or activators? Both are same. I have taught you in the first unit. Do you remember? So, activators are nothing but the machine or motors like hands, legs. So, these things you call it as activators. With this only we can do something on this world. What is sensors? The sensors are the one through which we can get the input from the environment. So, my eyes, my sensing thing, these things you call it as sensors. Okay. So, robots are equipped with effectors as well as sensors. Some of the sensors that robots use are GPS, location monitoring, then similarly range finders. So, all these things are some of the applications of sensors. Okay. So, these are the sensors that normally robots uses to sense the location and other things. So, robots, you remember that robots are equipped with two things. One is effectors as well as sensors. So, these two things, it comes under hardware of the robot. Okay. So, next, the robots, if you see it as of three types. The first one is manipulators. So, manipulators is nothing but it's a robot with fixed arm. So, if you see, the machine cannot move. It doesn't have any leg, it does not move, but it has an arm so that it can pick an object from one position to the other position. Okay. Robo has an arm, it does not move, but picks the object and moves from one position to the other position. So, that you call it as manipulators. The second one you call it as mobile robot. So, mobile robot, it has wheels, it can move from one position to the other position. In the meanwhile, it has the arm also to pick up the things. Okay. So, the mobile robot has wheels so that it can move from one position to the other position. The third type of robot, you call it as mobile manipulators. So, mobile manipulators is nothing but humanoids. So, I hope you remember Sophia. Who is Sophia? So, that robot seems to be the first citizen, robo-citizen of Saudi Arabia. Okay. So, the robot that was given the citizenship, first robot to be given a citizenship that belongs to Saudi Arabia, her name is Sophia. Okay. So, that robot, if you see, is a humanoid. So, it resembles like a human being. Whatever the task it is done by human being, it is done by robot. So, that is an example for this mobile manipulators. So, there are three different robots. The first one you call it as manipulators, second one mobile manipulators, third one mobile robot. Okay. So, these are the three types of robots or categories of robots. So, next we will see what is robotic perception. So, how a robo gets the input. Perception is nothing but input. So if you take a robo, how it gets the information from the sensors. So if you see, I have already covered it here. It uses sensors to get the information from the environment, right? So when that robo sees an object in the environment, it has to map that thing into its internal state. Internal representation is nothing but the knowledge representation. So if you see a certain object there, it has to select that object, it has to map with the knowledge it has, and it has to find what it is. Do you understand? So I see something, an yellow object over a long distance, if I am a robo. So I have to map what that yellow object will be. So that has to be sensed and compared with the knowledge that is present in my knowledge, and I have to finally infer that it is nothing but a ball. Okay. So this kind of internal mapping is done with the help of robotic perception. So here also some problem arises, because robos normally it use the sensors, right? Even the cameras, with the help of cameras, it senses the objects in the environment. So what happens if the camera is dirty? So it cannot capture the environment from the things from the environment, right? So the image will be very much of noisy. So the noisy environment, unpredictable environment. So these will be the difficult part while perception of robots. Okay. So the noisy environment as well as the unpredictable nature of the environment will create some problems while perception on robots. Okay. So it can, on noisy environments, the robots will be feeling very much difficult to percept on those things. Okay. So the next one is the localization and mapping. So here it uses Monte Carlo algorithm. So if you see, if there are different objects in that particular environment, it will sense all those objects as small dots. Highly density area, less density area. So you can consider a map like this. If you see, here I will have many objects. Here one object, two objects, likewise. So it can identify this as a highly density area. So like this kind of mapping and all can be done with the help of Monte Carlo localization. Okay. So with this, it can identify the things in the real world. Similarly, if you see the other type of inputs that the agent can have is sensors to sense the temperature, to smell the odor, to sense the odor, and also acoustic signal, sound signals. So these are some of the other sensors through which the agent can get the information. Then if you see this machine learning in robots. So if you give some data to the machine can learn by itself. So machine learning is nothing but a machine that can learn by itself. So there are different categories of learning like supervised learning. So supervised learning is the one where the agent is taught what it should do and what it should do not. For example, if you take a car, if you are moving to a driving school to learn how to drive a car, the teacher will tell you what is brake, what is steering, when to apply brake, when to apply the clutch and other things, right? So there is someone to teach you what you should do and what you should do not. So this you call it as supervised learning. There is another category of learning that you call it as unsupervised learning. So unsupervised learning, there won't be anyone to teach you what you should do, but you will be learning by yourself. So if you fell down once while jumping, then the next day when you go through the same road, you will be careful, right? You will be very careful that the same mistake you won't do again, right? So this kind of learning you call it as unsupervised learning. Then there is another kind of learning that you call it as self-supervised learning. Self-supervised learning is nothing but with your own data you are going to learn again. Okay, so that you call it as self-supervised learning. So these kind of learning methods can be applied when you are using machine learning in robots. Even you can learn with the data that you have. Okay. Then planning to move. So when the machine is planning to move, actually it faces some kind of problem. The first one is point-to-point motion problem. Point-to-point motion problem is, so of course the agent or the machine plans that it has to reach a particular position called X. So accurately to that particular position it has to move. So sometimes it is not that much easy for it to reach the position that X. So this problem you call it as point-to-point problem, unable to reach a particular designation, namely X. The second kind of problem you call it as complaint motion problem. So complaint motion problem is you decided from X you are about to move to a box or a position Y. Okay. So when you are moving, when the robo is moving with its wheel, it found an obstacle in between. The robot doesn't know what to do when there is a block in between, a brick in between when it was moving. So this you call it as complaint motion problem. So when the robo is moving to its destination path, it meets with some kind of blocks or some obstacle. Because of that it cannot move further. So this you call it as complaint motion problem. And the third one you call it as path planning problem. So if you want to move from a position to the another position, you have to do or choose a path. Okay. So through this path I have to move so that I can reach that particular designation. So that is also not that much easy. So this kind of problem you call it as path planning problem. So if you see here in path planning problem, there is two methods. The one is configuration space. So configuration space, if you see, it is a state of a robo which is defined by its location, its orientation and the joint angles. Okay, when it shows the motors when it is fitted. So with this location, orientation as well as the joint angle. So with this three, you create a configuration space. Okay. So the another one is cell decomposition method, where the whole space of a room or the whole search area is split into small region called a cell. So if that particular small cell, if the object is there, it will be easy for it to identify. So that kind of method you call it as cell decomposition method. The last one, if you see, it is planning uncertain movements. So what happens if uncertain things happen? Suddenly if something happens, if when you are crossing a road, if suddenly some car comes, what you have to do? It was not planned. Suddenly it happened. So during this uncertain environment, what to do? Okay. So if you see, uncertainty is nothing but it is due to partial observability it happens. Even when I am, if I assume myself as a robo and I am sensing the information of this environment with the help of my camera. What happens if my camera gets dirty? I couldn't see anything, what happens in the real world. So during this situation, how should I behave? So that you call it as planning during uncertain movements. So here you can use approximation algorithm. Yesterday it was raining, today it is raining. Will it rain tomorrow? Yes, it will rain tomorrow because continuous there is 2 days of rain. So the probability is that the next day also it will rain. So this kind of approximation algorithm can be used to avoid this uncertainty. Okay, so when you are unable to predict, you can use this approximation algorithm to predict certain things. But the disadvantage is that there is a possibility of errors also. Errors may occur when we are using such kind of approximation algorithms. Okay, so this is all about the robotics. So in today's session, I have taught you the 3 types of robots. Then what are the hardwares of robo? What is robotic perception? How it gets the input? And I have also taught you how it is planning to move, how it can move, and similarly planning to move during uncertainty when it is not unsure of the environment or uncertain plan. Suddenly if it needs to do certain planning which is uncertain of how to manage. Okay. So these are the things which I have covered in today's class. So with this we have completed our 5th unit. Okay. Thank you.